was established to help scale the impact of data and AI in the humanitarian and development space. We're a team that is very much focused on bridging the gap between what you would imagine as a model and data-rich private sector and the data-hungry humanitarian and development sector. So this is really our goal. We're founded on 3 core principles. That is a multi-stakeholder collaboration. We want to try and make sure that data insights get into the hands of people that need it when they need it most. And then finally, we rely on proven AI technology to deliver this. Now, I think many of you are familiar with the landscape that we're in today. And so some of the numbers are pretty scary. In 2025, 300 million people across 73 different countries in need. And by the middle of the year, only 19% of the $45 billion ask was met. That is 40% less than the year before. So you can read between the lines. It's pretty obvious. Responders need to be able to do more, and they need to be able to do more with less. And here is where AI can really help increase and expand the scope and the speed at which people can respond. Now, AI can't really solve the challenge of finance, but this is a challenge that it can address. Situational awareness is generally quite slow, and that is because the sources of data that are used to actually respond are not really fit for purpose. We get highly accurate household surveys, highly accurate census data. It's just not timely. It doesn't really help in a crisis. And then, of course, there are alternative data sources. So we have telco data, we have satellite data, but making sure that the data gets into the right hands of the right people when they need it most is a challenge. And so even though the data exists, it's not necessarily where it needs to be at the right time. So what can AI do? What can AI do that humans cannot do? It can see more, and it can see more faster. So we can use AI models to process satellite imagery. We can process remote sensing data. We can process remote signals and telco data. We can do it at a pace that no human analyst would be able to compete with. We can also reach areas that generally are unreachable, either because there are not enough teams available, resources available, because the areas are dangerous to enter. So here we can rely on remote sensing information and have models do the analysis. And what we really want to do is free up people. We want humans to not do the laborious and tedious tasks of counting or classifying. We want people to be making the decisions, the judgment calls, to be able to take action. So this is really augmentation, not replacement, right? We want to multiply the reach and the scale and the impact at which we can do these things, and AI becomes a tool for that. It's also really important to keep in mind there always needs to be a human in the loop, and all our solutions are built with that in mind. So Disha has been around for about 2.5 years now. We've developed and launched 3 products. The first one is a damage assessment product, and this one has been built in partnership with Google. And our primary user for this solution is UNISAT, so the UN's satellite center. And we use AI here to do automatic analysis of building damage using satellite imagery. So we use 30 to 50 centimeter resolution satellite imagery, and we compare pre- and post-disaster imagery to identify where buildings have been damaged and where buildings have not been damaged. The second solution, which Janine will speak about later, is our socioeconomic mapping solution. And this was built in partnership with McKinsey's Quantum Black team, as well as Globe Telecoms in the Philippines. And here we use anonymized mobile data to track populations, population density, population movement, as well as poverty levels in the community. And we use that data to help with targeting. Again, it's important to call out, it is anonymized data, so it's anonymized at the source with Globe, with a telco. So we don't receive any PII data on our side. So we have maximum value, but also maximum protection for users. And then our last solution is refugee settlement mapping. And so here what we do is we extract shelter footprints from refugee settlements using satellite imagery. And again, this is a solution that we built in partnership with Google And our primary user here is UNHCR. And I'll get into the details of all of these later. So building damage assessment. Let's start with what is the first question people ask after a disaster? What is still standing? Where do we send resources? Which roads are still usable? Where are shelters going to be most needed? And we know that manual analysis is slow. And we've baselined the work that we do against some of the work that UNICEF does. And they do incredible work and at an incredibly high standard. But having no data for the first 5 or 6 days can really hamper aid operations. So what we're trying to do is reduce the time to insights. These insights might not be perfect. They might be 80, 85% accurate, but 85% accurate is better than no data at all on day one. How we've put this together, there are 3 models that we utilize. We deliver 1 assessment and there's 1 human analyst at the end of the process. So first we find buildings. We run a model called Google Open Buildings. Don't be fooled by the name. It is not an open source model yet. It's a proprietary model that we have access to through our collaboration with Google. It's highly accurate at identifying building footprints. And once we have those building footprints, we move to the damage classification step. So we use the building footprints as a baseline for what exists in the area. We then run a model called Sky. We run Sky in 0-shot form, which means it's the base model that is being run to analyze what buildings have been damaged in the satellite image. And Sky runs fairly quickly, but it's not super accurate at this point because it's not contextualized. It's trained on general data, so global. And when you're looking at a specific disaster, obviously you have some uniqueness in every different setting. We can then also run the next version of the model, which is a fine-tuned version, a trained version of the model. And so in the middle, there is a process where we annotate some data. And don't worry, I'm going to show you all of this as we get into it, where we create some label data. We use that label data to actually train the final model, which gets run. And then an expert can analyze the outputs of the building footprints, the outputs of Sky, and the outputs of the fine-tuned model. We can run the video now. So what you're seeing here is what the solution looks like in practice, okay? As you can tell, you require some technical expertise at this point to be able to run it. It is running in a Colab notebook. And this is not something that is massively accessible in this state, right? So we worked with UNICEF on how we can improve this. What you see here, I'll just quickly tell you, this is the comparison of footprints and damage assessments to actually create label data. So this is a tool called Eagle Eye that we utilize to create the training data that we'll use for the final model. Here you can see what the outputs of that looks like. I believe this is in ArcGIS. This is really sped up, so hopefully you can keep up. And here is a view of one of the interfaces that we tried out to try and make it a little bit more user-friendly. So analysts could identify the area of interest. They'd be able to select the model that they want to run. The model runs, does an analysis in the buildings. That would be 0-shot. And you'd get an estimate of what kind of damage has taken place, right? So you'd almost see like a heat map of the damage. This is the model actually running, landing on every individual building that was identified in the first run, and then analyzing it for damage or not. Now, this interface we decided was a little bit too busy and a bit too complex for a user to deal with. And you'll see where we landed afterwards. But there are a couple of more things in this video that I would like to show you. We started running this for damage assessment. We also identified a number of other use cases. So refugee settlement mapping, density detection, flood mapping, and actually being able to apply custom models as well. So here are just a couple of demos. This is what it would look like if we were running refugee settlement mapping. And I'll give you some data in terms of how long some of these models take to run compared to human analysis as well in a couple of seconds. I believe this is the roof density mapping. And all of these are running in real time with somebody controlling it through a Colab notebook, right? It is unfortunately, as I said, something we realized training analysts to be able to do this sort of had a high bar, I guess. It took a lot of time. It wasn't really efficient. And we knew if we wanted to scale this to non-technical teams, this just wouldn't be the way to do it. And so we moved on from this approach. We can skip back to the presentation. There we go. Okay, so we've moved on from that approach and we decided to build this into a very simple user interface. To be able to run the entire model, you now need no technical skills. You don't need to make sure that your Colab notebook is up to date. You don't need to worry about package dependencies and all the things that you would normally need to do when trying to run models. It's really simple. You start by creating a project. Now we pull all the active disasters from UNDAC at the moment, but if it's not under UNDAC, you can just create your own project. You upload a file which contains the area of interest. So it's the top image that you see over there. And then you upload your before and after satellite images. Again, 30 to 50 centimeter resolution gives you the best results. Once those have been uploaded, you run your building footprint model, and it literally is as easy as saying, run the model. Once you finish running the model, you'll get your results, and you can run the next step in the process, which is the zero-shot model. Zero-shot gives you a heat map of damage, so you immediately have some insights that you can work with. You don't have to use those in the state that they're in. You can then move to the next step, which is creating training data. You use data that you've gotten from zero-shot. You compare pre and post images like you can see in step 5 over there. You annotate around 300 to 500 buildings. So depending on the scope of damage, you only need about 300 to 500 buildings to be able to train the model efficiently. And the reason you need that annotated data is to make sure that the model understands the context of the environment that you're analyzing. Once you finish training it, you run the final inference and you get output. Right? Your output becomes a GPS coordinate with a label, damaged or not damaged. What we found is we can cover around 7 times the area, 6 times faster than human analysts. We can get those insights out in under 24 hours. The only caveat around the 24-hour number is that you actually need satellite imagery for it. And often with certain types of disasters, there might be cloud cover, so you might not get good imagery. So it might take time. You might need to do 1 or 2 runs. But generally within 48 hours, we've always gotten results out. Just to give you an idea of the speed at which the model can operate. So one activation covered 1,200 square kilometers in Bangladesh. We labeled 477,000 buildings in a single run. That run took less than 2 hours. This is not something that you can compete with as a human, right? Now, if this run got you 60, 70% accuracy, you can immediately see which areas need the most attention and where you need to be focusing. From here, you can run the next step of annotation, you can run the fine-tuning step. Probably the run would take around 2.5 hours with a fine-tuned model. You'd get more accuracy, you'd cover the same number of buildings. So it's a massive leap forward in the potential of what we can do with the data that we have. This is just a little example of what a UNOSAT assessment looks like on the left and an AI-assisted assessment on the right. The UNOSAT assessment is something that might take a couple of days to complete. The assessment on the right, something that might take a couple of hours to complete. So it really is telling the same coverage, if not larger coverage, at a fraction of the time. Okay, I'll move on to the next solution. This is our refugee settlement mapping solution. So today there are around 1,000 formal refugee settlements, many informal as well. And most of these don't have up-to-date shelter data. So it's either out of date or there just isn't any available. What we're trying to do is extract individual shelter footprints out of a specific settlement and replace the manual enumeration. This is also something that is powered by the same open buildings model that we have from Google. And To run a building footprint model, on a very large area, it takes around 25 to 45 minutes. Now, we've built this for UNHCR, and in the past, UNHCR and UNISAT have done manual analysis of building footprints using satellite imagery. But the numbers that we got back were evaluating 30 to 40 settlements could take anywhere between 12 and 18 months. This is a very long time. Whereas with this model, those same 30 to 40 settlements could be done in a week. So we've built this solution. We're about to launch it with UNHCR. And really what this allows us to do is monitor expansion or shrinkage, scope, density of these settlements over a period of time. So now you can generate time series data at a fraction of the cost. You'd never be able to do this with manual enumeration. You certainly wouldn't be able to do this with analysts analyzing satellite images. Now, just to give you an idea of what the comparative view looks like. On the left, you see manual annotation. So this is where a human has gone in and drawn with an ArcGIS or GIS interface, a little polygon around every building. On the right-hand side, the model has inferred where buildings exist and has automatically generated those. So you can imagine one person drawing a little square around every tiny little block that you see versus a model doing that in 25 minutes. The idea here is that we can run this on a regular basis. So you can get monthly or quarterly updates of settlement growth and shrinkage, something that we just haven't been able to see in the past. Okay, so the third solution is our socioeconomic mapping solution. And so this jumps to the next question. Where do people go and who needs help first after disaster? So the Philippines is hit on average by 20 typhoons a year, and populations move within hours. Data is obviously not as fast to follow. Census surveys lag by weeks, and movement of these populations need to be tracked within the first couple of hours. To enable this, aside from building the platform with McKinsey, we've signed the first evergreen data sharing agreement with Globe Telecoms in the Philippines. So what this unlocks for us is access to subscriber data. So we get data from 50 to 60 million subscribers on a daily basis. We have the ability to track those subscribers, and it's anonymous, but the ability to track them throughout the day with 24 data points per subscriber per day. This is unfortunately a huge amount of data. It's actually hundreds of terabytes, so it's too big for us to process. So we've reduced that, and we basically get a top location for every individual of that day. It's still a large data set to analyze. As I said, this is something that we've built over time, and Janine will come up now to tell us a little bit more about this. It's been a great privilege to work with CRS as our core partner there to validate our solution. And yeah, we're just very happy to have Janine to talk about it.
Okay. Thanks, Sandro. So, yeah. I'm Janine Cayetano. So I am a digital programming technical advisor. So I've been supporting CRS programs towards the use of GIS, data visualization, data analytics. We know ICT 4D or technology is a tool. It is really effective in using it for development as well as different humanitarian programs. So as well as like using our mobile phones, digital data collection, and then there's also GIS mapping towards the community as well, capacity building the community on how to use data, as well as using it in developing countries like the Philippines. So when UN Global Pulse reached out to us in order to partner in using the Disha dashboard, we were really honored to be able to use it in real time, especially that one of the questions that we asked after the disasters is, where do we put our efforts or reliefs in helping the community? So this is actually what responders actually see is where we should put our best efforts. Um, and yeah, in 2025, the social economic mapping was in production across the Philippines. So we were able to, so typically in the Philippines, we experience about almost, yeah, what Andrew said is almost 20 typhoons in a year. So like that includes flooding, flash floods, landslides, even I think volcanic eruption that we're experiencing actually now. And one of the things that we made use of this is to be able to know which people or which areas are really affected or where do people go, and also combining it in where is the vulnerable areas based on the socioeconomic data or where is the poorest communities. So in here you could actually on the um, left side or in the middle side you will actually see the outflow or the net outflow of which areas are affected. So we are able to see where people are going, where are people coming from, and what areas are really affected. So meaning if we see like area A, there's a lot of people going out, and where do people go, possibly go? And in the nearest municipalities that probably are not affected or probably are evacuating. So the good thing about here, you can see the teal color is the inflow, and then the red is actually the outflow, is we're able to create insights on how areas are affected. And then we could actually, during the process of building this, we worked with Andrew and the team and even McKinsey if we could overlay the track of the typhoon as well. So in that we are able to put insights. Okay, here are the areas that are affected by the typhoon, and then here are the outside boundaries that could be the ones that are not affected and people are going due to that it can be evacuated. So yeah, over time, like we saw in one of the typhoon, it's called Fengwang, an international name, and a total of 129,000 net inflow subscribers are visible in the social economic mapping within hours of landfall. Actually, a story here is initially we were able to see like the results. I think the first phase was about 5 days because there's a lot of data, and then we've come down to 2 days up until we were able to see it in almost real time, right? So that helped us to be able to see immediately the next day, to see where we'll put our efforts in, communicate with the local government or local agencies. So, yeah, the CRS experience in piloting Disha in the Philippines, we were able to validate and refine the dashboard with UN Global Pulse, McKinsey, and contribute to a much more operational feedback, um, to be able to see where our needs are, right? So it helps us locate vulnerable locations, population, detect major movements within the country, and then from validation to anticipation is to be able to prepare anticipatory action as well as emergency coordination with local agencies, as well as local um, organizations in building public and private partnerships for long-term resilience. So yeah, I think we could play the video before I, yeah. So here's how we are able to access the Disha dashboard. So we actually have a um, a focal point within CRS Philippines for the emergency response to help us be able to access the data anywhere. Actually, even though we don't experience a certain flooding or a certain disaster during that time, we are still able to create some access to give us on where people are as well as the vulnerable populations. So yeah, that's one thing that I mentioned earlier on how we could update the dashboard, being able to overlay the information like the track of the typhoon, the track of the typhoon. And the good thing about here is we're able to see it on, we call it barangay level in the Philippines. So I would say probably a community level of population movement. So yeah, you could see the different measures that we are able to apply, as well as we've also asked McKinsey as well as UN Global Pulse to be able to view where the facilities are within the country. So yeah, we started with like a municipality level towards a barangay level. So probably you could see here is showing at on the municipality level. So yeah, I think you could stop that. And yeah, just to overall, like I've said, can we go back to the presentation? Yeah, like I've said, Disha helped us demonstrate on how responsible partnerships with telecom, digital partnerships and technology companies can unlock humanitarian value, as well as being able to communicate this within the community. So yeah, I'll put it back to Andrew. Thank you.
And yeah, I think that what Janine mentioned towards the end, just in terms of going from municipal levels to cities down to barangays, again, it's feedback that CRS and users have been giving us. What we've actually implemented now is taken that down to an even more granular level, which is a Voronoi diagram. And so what we do is the mobile data is tracked against cell phone tower connection, right? So to get a top location for an individual, you're looking at has that person's mobile device latched to a tower? Have they used data? Have they called? Have they texted? Have they received any of those? Based on that data, we identify a top location. And so what we now do is gather all the data around the nearest cell phone towers. So we have a list of cell phone towers from Globe Telecoms. And so it's an even more granular level now than what you would get from municipal boundaries. And you're looking at real tower level accuracy. We saw that now with the Mayon volcano that just erupted. And we could get data out of that within hours. And a number of different agencies and partners were calling me to get insights out. And I was literally in the dashboard within 5 minutes, insights out, quick screenshot, and they were able to access the data and make decisions. Now, I'm gonna bring this to a close in the next 5 minutes, and we'll have a couple of minutes after that for questions. But Disha is in sort of full scale-up mode right now. Damage assessment has been used across, probably these numbers are old now, probably 20 plus disasters. Same with socioeconomic mapping. And really the story that I want to tell is that it's not a story of Disha doing anything by itself. It is very much a coalition and a collaboration. And without private sector and humanitarian partners that we've had supporting us, we wouldn't be here. Disha just happens to be the vehicle that is making sure that this moves forward. And as far as UN entities go, we're a vehicle that was designed to partner, which is why we've been able to do that so effectively. And I think the strengths of both private sector and the humanitarian sector coming together is really important to call out. Private sector brings agility, deep technical expertise, and the ability to mobilize resources really quickly, while the trust and neutrality from the UN and from humanitarian organizations are absolutely necessary. And I feel when these two come together, I think that's where technology meets legitimacy in a sense, and these solutions can really lead to amplified impact. So with that final word, no single actor can deliver this alone. And as you can see with everything that I've spoken about, there's data, there's AI technology, and there's stewardship involved. And that's what helps operationalize AI in times of crisis and when it's needed most. So each piece is necessary, and none of us could do this by ourselves. Great, thank you. Happy to take some questions. I think we've definitely got enough time. So.
Hi, thanks, Sandra and Janan.
And feel free to also ask Janine questions.
Yeah. So I've got two questions, if I may, on two different solutions. So great that Disha is, I mean, you're opening it up, you're asking for applications for other people to use it, particularly with the damage assessment. When a crisis hits, if an organization can run that analysis, great, but there's a lot of humanitarian organizations that are a lot smaller or don't have the resources to be able to do it. Are you imagining that the outputs are also going to be shared amongst the community on something like HDX or Relief Web or something like that, so you don't actually have to be running the analysis yourself or have multiple people run it?
That's a really important. It's a good question. It's a really important question as well. And some of the feedback that we've gotten from the community and from UNICEF and other entities who are known to put out analyses. We were cautioned in a sense to also not put out too much analysis, because lots of organizations are doing this. Lots of people are flooding the ecosystem with data, and it's not always clear what data is reliable, trustable, what should you act on and what shouldn't you act on. So first of all, we are certainly looking to make this more broadly available for people to utilize themselves. And there are a number of organizations, non-UN organizations, that are looking to utilize the solution. At the same time, we have been in very close collaboration with HDX. We have our page set up on HDX, and so we're positioned to start actually publishing our data. One thing to just make very clear, that data is, it's meant to be very quick, early analysis, so it'll be unverified data. But what we hope to do is then link it to the verified data. So once UNICEF has had the time to verify it, to link that to verified data. Now, just to quickly add on to that, in terms of the levels of accuracy and sort of trust that you can put in the data, when we started out with both the building footprint model and the damage assessment model, UNICEF went through very rigorous validation of the outputs of both. That rigorous validation went, for the building footprints in particular, to, okay, we now eyeball the data. We kind of look at it, we say, yeah, this looks like it's sort of close to 90 to 100% accurate, good enough. Now they don't even eyeball the data. They run that building footprint model on every disaster, and the numbers are used every time. So the levels of trust have increased dramatically. And the same now for our building damage assessment. In the beginning, it was very rigorous validation. Now we can eyeball the results, look at the precision recall and the F1 score of the model, and it's good enough to be able to push out and publish. Sorry, it's a very long answer. But.
No, that's very informative, thank you. And my second questions are around the population movements from call data records and stuff. Working with MNOs is historically difficult. Humanitarians, they don't want to engage with, even their own governments, they don't like. I'm wondering how much work has gone beyond the Philippines to try and find other MNOs willing to provide that information, because there are organizations like Flowminder that have a similar solution, been trying to get more and more organizations for decades now, and it's very difficult.
It is. It's an ongoing challenge. I think what so it took a long time to get this established. I think kudos to Globe Telecom for being such a willing partner to work with us on this. What we've done, I think, to help scale this is we've built a solution in a manner that it is provider agnostic. And part of what we're looking to do is also see how we can actually open source the technology. A pathway to actually deliver this is to make sure that the MNOs themselves are able to adopt the technology and release this kind of data to humanitarian organizations. If they're not so comfortable releasing their data for analysis, can they release the actual outputs? And so we're in conversation with a couple of MNOs along that pathway. But yeah, it is. It's a challenge, and it's not right now, not yet. Oh.
Hi. In the context of the Philippines, because I'm from the Philippines, and thanks for sharing that. Actually, so what kind of data do you get from Globe? Because in relation to my second question, if you're already getting data from Globe and you're communicating with the local with the LGUs, would you then be able to just directly communicate with the people affected, that just to warn them?
That's a really good question, and that's something that we're actually working on right now. So the data that we get from Globe, first of all, it's location data. And the location data helps with the population movement and density mapping. We also get data on airtime, sort of mobile money type records. And the reason we get this data is to infer the poverty levels. So we have census data that we have to baseline poverty levels in communities, but we also have a model that actually analyzes some of the top spend for the week, average spend or average savings on an account for the week. So there's, I think it's about 25 features in that data set that we analyze to infer poverty levels. So those are the two key types of data that we get from Globe. Yeah, I think that the next step for us is, and we're workshopping this with Globe in 2 weeks, is to see how do we take that next step? Because initially this was something that Globe started doing as a, AI for good initiative, but then they started seeing the value and the impact and sort of the value attributed to the work by partners. And they want to actually get more involved in this themselves. Initially, it was, here's the data, you go figure it out. That relationship has changed to, what else can we do? And there are a couple of other partners, specifically partners in the space of direct cash distribution, that we're also speaking to see how can not just notifications be sent, but also sort of anticipatory funding be sent out to communities that may be hardest hit.
Good morning. Mine is a very simple and straight one. What has been one of the biggest, or some of the biggest challenges in terms of moving from AI pilots to scalable operationalization?
That's a good question. I think one of the things that we never wanted to do was we never wanted to be a pilot that doesn't go anywhere, and I think because of that, the focus on partnering with very strong, reputable technology partners has helped. So I mentioned it right in the beginning when I said scaling proven AI technology. And that keyword proven is what's helped us not fall into the trap of pilot. The technology that we're using is not technology that someone has just decided to try out on a whim. It's deeply researched, it's very robust, and it's helped us deliver results from day one. And I think that has helped also change the perspective on what Disha is doing and what Disha can do. So I think finding the right technology partners and being able to deliver from day one, not say, I am just experimenting, but saying, here I am delivering something that delivers value, and being able to show sort of with numbers that it is actually doing that. There's a question here.
Okay, thank you. My question is specifically about the population movement aspect. So especially in the area where there is no mobile towers coverage or access, is there any possibilities of this use? For example, like we have this Starlink access everywhere now. I don't know if that's something that can be usable to replace this mobile tower context, especially in the area where there is active conflicts are happening. So it might be very difficult, to get access to the mobile data service and the like. So is there any kind of alternate option toward this one?
So again, there I think the challenge comes to who's willing to share data with us. I think when it comes to mobile providers, like there are some challenges. We have looked at using social sensing data, and so I think wherever there is Starlink, there is access to social media, we can get social sensing streams. So streams from Twitter and streams from Facebook or streams from Instagram. Some of that does come with location data, but that is infinitely harder to access. Yeah, we haven't had any success in being able to do that yet. So at the moment, we're limited to where mobile towers are accessible. People can reach data through more traditional means. Yeah, so we're a bit limited there. We have been looking at using satellite data though for a population estimation. So that is a possibility. Things like nighttime lights. So there are a couple of other ways to estimate population, but it's not as it wouldn't be as granular as what we can get with what we have today. Yeah.
Thank you. Thank you. Thank you very much for sharing. And actually, to what you just mentioned, there is still with the tower, with the cell phone towers, the problem with the energy. So they could run out of energy. Some of them use diesel, for instance, as a backup source of energy. But if you're having a huge problem like flooding and you cannot fill it out again, so then you can lose the tower, and it's another challenge. And I think satellites could help a lot. By the way, I'm Alvaro Jose from Data Friendly Space, and I have a question for Janine. Aside the metadata you currently get from the populations or from the people, do you collect any kind of information out of them, because they agreed to share data with you? So is it possible to get some collective intelligence out of these people and get insights or more details about what is happening?
Since this is the last question. So I think, like what Andrew said, like moving forward, since this is still on a development phase, is after that information we actually want to validate on the ground by being able to communicate, especially on like the barangay level, the local government units, in order to make sure that what we're collecting, what we're getting from the telco data is correct. Especially that, from people from here, from the Philippines, actually Globe is just one of the telcos. There's actually two. So the other telco companies, like what Andrew said, it really boils down to who is interested in partnering with us. Another challenge that we're facing is the other telco also covers a lot in the rural space, so it actually helps us to, if we get that, I would say probably 80% of the data coming from Globe, the 20% of the population probably uses the other telco. Why don't we validate on site and see if we're getting the right information, as well as they are also being involved, using the science and the social science of the information. So yeah, thank you.
Okay, I think that's the end of the session. Thank you, everyone. And if you have any questions, please feel free to find me or find Janine afterwards. Happy to talk through anything, and also happy to show you more of the solution. That would be helpful. Thank you.